Okay, I just want to give a little factoring summary of what you could possibly get in grade 10 as far as factoring. I have 4 examples here. Pretty much that's it in grade 10. You're not going to get anything that probably isn't one of these examples. Well, 95% of the time. Okay, so, well, let's start with number 1 here. I want to factor this thing. Factoring's the opposite of multiplying. This has already been multiplied. Okay, I want to go backwards. First thing you need to look at when you're factoring is there a greatest common factor between your terms? In this case there is. There's a 2. I want to remove that 2. I want to factor it out of both terms, okay? So when I take a 2 out of 2x squared, I divide the 2 away. What do I have left? I have x squared. And when I take a 2 out of 8, when I divide a 2 away from 8, what do I have? I'm going to have 4. Okay? So check it as you do this. If I multiply this back again, I get 2x squared. Okay? And I get 2 times negative 4 is minus 8. This is the same as this. I can't change it. Okay? It has to be the same thing or I made a mistake. Now, anytime you get 2 terms, including this one, you need to ask yourself, is this a special trinomial? Is it a difference of squares? What is a difference of squares? Well, this happens to be a difference of squares. This is the square of x. X squared. This is the square of 2. This is 2 squared. So you ask yourself a question. Can you take the square root of it? Can you take the square root of x squared? Yeah, that's x. Can you take the square root of 4? Yes, that's 2. There's a minus in between the 2 terms, so this is our definition of a difference of squares. Okay, how do we factor that? Well, I still have my 2 there. Just carry it down and then ignore it. The square root of x squared is x. So you throw that in both sets of brackets. The square root of 4 is 2. You throw that in both sets of brackets, and then you just put in a plus and a minus. Okay? Of course, it doesn't matter where you put the plus or the minus. The first one, second one, doesn't matter. This is now fully factored. I cannot factor anything out of here, anything out of here. Okay? These are the factors of 2x squared minus 8. This is one of the factors, 2. This is another factor, x minus 2. And this is the third factor, x plus 2. Of course, what you want to do is check this. Okay? If I FOIL this, I get x squared plus 2x minus 2x minus 4 times all of this times 2. So what's that? Well, 2x take away 2x. These middle terms cancel. Okay, and I get this again. Okay, remember, factoring's the opposite of multiplying. If I multiply it all out again, I'd better get the same thing. Okay, that's what I started with. So now I know I got the right answer. Okay, that's just checking it. Okay, this of course is the answer. This is the original question factored, fully factored. This again, we have 2 terms. Ask yourself, is that a difference of squares? Can I take the square root of that? Well, I can take the square root of x squared, but I can't take the square root of 3. So that is not a difference of squares. But step 1 says, is there something common to both these terms? Factor it out. In this case, yes, there is. There's a 3 that's common in this term and this term. I can factor that out. Okay? While I'm at it, well, you might notice there's also an x in both terms. I want to factor that too. Okay, take out the greatest common factor, not just a factor. Otherwise, you'll still have some more work to do. Okay, if I take 3x out of 3x squared, what do I need to multiply this by to give me this thing? An x. The other way of thinking is, what is this term divided by 3x? It's x. And how do we check? Well, we just multiply this back, 3x times x, and that gives me 3x squared. If I take 3x out of 6x, what do I need to multiply this to give me this original term? It's a 2. Okay? This is not a difference of squares because it wasn't before, and well, it still isn't. What can I do? Nothing else. This is fully factored. Okay, there's a factor, there's a factor. This one's done. Now we get our typical trinomial, 3 terms. Okay? They're always going to look like this. Okay? We want to factor this thing. This is the easier because a here is 1. So we should be able to just do this by inspection. We just want to throw 2 sets of brackets down and say to ourselves, what multiplies to 6 times 1, which is just 6, and what adds to this middle term, negative 5. Okay, what 2 numbers? And factors of 6, well, it could be 3 times 2, it could be 6 times 1. Both of these might add to 5, so we got to be careful here. Okay, which ones multiply to 6? 3 times 2, 6 times 1, and what adds to negative 5? Well, to get negative 5, I would have to have this. But then this wouldn't multiply to positive 6, it would multiply to negative 6. This also multiplies to positive 6, and these add to negative 5. So those are my 2 numbers. Okay, negative 3 and negative 2. But let's check it. Okay, let's FOIL this thing out. X times x is x squared. Negative 2 times x is minus 2x. Negative 3 times x is minus 3x. Negative 2 times negative 3 is positive 6. And if I collect these 2 terms, I get, in fact, minus 5x. And that's what I had to start with. Once I remove all this mess here. Okay, so I'm good. This is this trinomial factored. Looks like that. Okay, I can't do any more factor. This number 4 is also a trinomial. Okay, but this time a is not 1. So we have a new procedure for something that's a little harder than this. Because while this is still possible to factor this by inspection, we might be here for quite some time before we figure out what multiplies to negative 60 times 10 and what adds to 25. Okay, if you see the 2 numbers, feel free, but I don't. But what should we be looking at first here? Is there a greatest common factor I can take out of each 3 terms to make my life nicer? And in this case there is. If I take a 5 out, 5 goes into 10. In other words, 10 is divisible by 5 2 times. Okay, 5 goes into 25x 5 times, and 5 goes into negative 60 negative 12 times. Okay, that's a little bit nicer. You might want to try this by inspection, but what we taught you to do is what multiplies to negative 12 times 2, that's minus 24, and what adds to the middle term 5. What 2 numbers? And you got a few choices for 24 here. Okay, 8 times 3 is 24, and they also add to 5. Okay, but I need to multiply to negative. So if I put a minus here, that multiplies to negative 24, and that adds to 5. What I want to do is split up 5x into 8x minus 3x. I still have my 5 out here. I still have my 2x squared. Okay, I still have my minus 12. And then ask yourself, is this the same as this? 8x minus 3x is 5x. Yes, it is. Okay, always want to check. Now, why did I do this? Because I want to factor this by grouping. I want to know what I can factor out of these two guys. Okay, I know it's confusing with this 5 here. What I recommend is let's throw it way over there and forget about it. Okay, I know I have to multiply everything in here by 5 when I'm done, so let's just put that there. What can I factor out of these two terms, 2x squared and 8x? I can take a 2x out, and then 2x times x is 2x squared. How many times does 2x go in 8x? 4 times. Okay. Out of the next two, minus 3x minus 12, what can I factor out? I can take a 3 out of here. Okay. But if I take a positive 3, what do I get? Minus x minus 12. Well, how do I make it look like this? That's what I need to do. Let's change the sign on that minus 3. If I factor out a negative 3x, that's got to be positive x. Okay, that gives me minus 3x. And then this gives me, that should have been a 4. Okay, positive 4. And then I got the same thing, don't I? Okay, and that's the key. I want the same thing in the brackets here. That's what I want to factor out. If I factor that out of this and this, then what do I have left here? I have 2x minus 3. Okay? So again, I removed this, I factored this out of both of these two terms. This is what's separated by, that minus right there. Okay, if I take this out and put it out in front, I multiply it by the 2x. And if I take this out, I need to multiply it by the minus 3. Okay? So this now is fully factored. Don't forget about this 5. Now let's just bring them back and put them right out front. Okay? So the factors of 10x squared plus 25x minus 60 are 5, x minus 4, and 2x minus 3. But again, strongly recommend you check that. Let's just do that quickly. That's 5 times, if I FOIL this, I get 2x squared minus 3x plus 8x minus 12. Okay, I can collect those, and that gives me 2x squared and 5x minus 12. Everything's multiplied by 5, so that's 10x squared plus 25x minus 60, and bingo, that's exactly what I got to start with. So now I know that's correct. Okay, fully factored. Let's remove my mess again. That's what it is. And that's probably as tough as they're going to get in grade 10.